Hey everyone, welcome back to ReMathable. This video is specially made for my grade 9 students and it's all about mensuration 2D. So if you're feeling stressed about your finals, don't. This video is designed to be more than enough to help you prepare thoroughly. And to make sure you're completely ready, the next video will be packed with past paper questions. Together, these two videos are all that you need to ace this topic in your finals. Now here's how this video is structured. We'll begin with the basic shapes. So we will revise all the basic 2D shapes: squares, rectangle, triangle, parallelogram, rhombus, trapezium, and circles, including semicircles. You'll learn exactly how to calculate their perimeter and area. Next, we'll dive into composite shapes, figures made by combining these basic shapes. We'll learn how to break them down and calculate what's needed. And finally, we'll go deeper into circles, covering sectors and segments, which is extremely important. But feel free to skip ahead if you're confident with any section and focus on what you really need help with. So let's get started and make sure this topic is 100% prepared. Two-dimensional shapes have length and width, but no depth. Okay. Now they may ask you to find the perimeter or area of 2D composite or basic shapes. So let's dig deeper into the basic shapes. But before that, we need to understand what perimeter is. So perimeter is the total distance around the sides of a shape. Okay. Basically, to calculate the perimeter, you just have to add all the lengths together. So adding the lengths of all the sides. So perimeter is the total distance around the sides of a shape. Basically, it is the sum of all outer sides. And we generally do not memorize formulas for calculating perimeters. Okay, we will memorize formulas for area, but for perimeter, let's do a couple of examples so that you would understand what perimeter is. Okay, so let's imagine this is the shape. And then we have this as the shape. Okay, and oops. Okay, let me use freehand then. Okay. So now what is perimeter? Perimeter is the sum of all outer sides or the total distance around the side of a shape. So as a student, I would always begin from one corner of the shape. I would put a circle or a dot, a big dot, and then I would trace the figure. And I would keep adding all the lengths till I would reach back to the dot. Okay, so we're going to add this length, then this, and this. So that will be the perimeter. Okay, let's start from here. So we're going to start from here. We're going to add this side of the triangle, then this length of the rectangle, the base, the length, and then the other side. And now we're back at the dot. So the sum of all these sides is going to basically be the perimeter of the shape. Okay. Similarly, for example, okay, so what is the perimeter of this shape? So it's the sum of all outer sides. Okay, so we're going to begin from this. You can start anywhere, okay? So we're going to add this height, this length, height again, the semicircle, the length. What about this? We're now going to add this to the perimeter. Why? Because we only calculate the sum of outer sides. So you're going to begin from one one corner of the shape and you're going to trace the entire shape, add whatever comes along your way until you reach back to the dot. Okay, so we're now going to calculate, add this length into the perimeter. So I hope it is clear as to what a perimeter is. Okay, we're going to do examples later, but here you just understand what perimeter means. And perimeter is measured in millimeters, centimeters, meters, or kilometers, right? The metric system. So you add all the shapes, basically millimeters, centimeter, meters, kilometers, the metric um, units which are used to calculate the length of something, right? Then the second thing that you can be asked to find is the area. What is the area? Area is basically the amount of space inside a shape. Is the amount of space inside a shape. Okay, so what exactly is area? So for example, this is what we calculated, right? Okay. So what was perimeter? I'm going to highlight what the perimeter was, okay? So the perimeter was this side plus this side, this side, this side, right, of this shape. Perimeter is the sum of all outer sides, right? What is the area? Area is basically the amount of space occupied by the shape. So this green thing is going to be the area. Okay? The space occupied by the shape. Okay, so this is the area and this is the perimeter. So I hope you just understand the difference between perimeter and area. How we are going to calculate is a topic that we're going to touch upon, but for now, just understand what these two terms mean. Okay? And area is calculated, or areas are measured in millimeter square, centimeter square, meter square, or kilometer square. Okay? Why? Because an area always involves the multiplication of two linear measurements. Okay, so for example, if this is 5 centimeters and 3 centimeters, okay, so the perimeter would involve adding 3 centimeter plus 5 centimeter plus 3 centimeter plus 5 centimeter, okay, but area would involve multiplying 5 with 3. Okay, so 5 centimeter into 3 centimeter. 5 centimeters multiplied by 3 centimeters. So 5 into 3 is 15 and centimeter into centimeter is centimeter squared. Okay, that is why area is measured in squared units always. Okay. But before moving on, just quickly recap the conversion charts that we have covered in class and in my previous videos as well. So what are the conversion units? Millimeters, centimeter, meter, kilometers, right? What are the conversion rates? 10, 100, 1,000. If you're moving forward, you're going to divide. If you're moving backwards, you're going to multiply, right? So for example, if you have to convert 12 meters to millimeters, so what are you going to do? Meters to millimeters. So you're going to multiply by 100 and then multiply by 10, or you can simply count the zeros 3 and multiply by 1, 2, 3,000. Okay, so using this conversion chart, we know that we need to multiply this with 100 and this is going to be 1000, sorry. This is going to be 12,000. Now, had they asked you to convert from 12 meters to kilometers, okay? So what's the rule? 1,000, and we need to divide. We're moving forward, so we're going to divide by 1,000. So divide by 1,000. So 1, 2, 3. It's going to be 0.012 kilometers. Okay. So please make sure that these unit conversions, that you're absolutely clear about them. You have no confusions regarding these. Okay. Now let's move on to the most basic shape, which is the square. Okay. So a square has 4 equal lengths. The formula for calculating the area of a square is length into length, which is basically L square. You should memorize this formula. As far as the perimeter is concerned, students tend to memorize the formula for perimeter as well, but I would recommend that you simply make a dot and start tracing the shape from one corner. So L plus L plus L plus L will be L plus L plus L plus L will be 4L. Okay, so this is the formula for calculating the perimeter of a square, but you do not need to memorize it. You can also figure it out by looking at the shape. Okay, but you need to memorize the formula for calculating the area of the square. Okay, now let's move on to the next shape, which is a rectangle. So this is the length of the rectangle. This is the width or the breadth. Okay, so the area, the formula for calculating the area of a rectangle is length into width. Okay, and the formula for calculating the perimeter is basically L plus W plus L plus W. Okay, so the perimeter is L plus W plus L plus W, right? This is L, this is W, so this is also going to be W and this is going to be L. So the perimeter starts from one point, L plus W plus L plus W. Okay, so let's collect like terms together. So this would become 2L plus 2W, or you can simply take 2 common and L plus W. Okay, all of these are correct. So these girls, make sure that the formula for calculating the areas is absolutely clear. You need to memorize it. There's no shortcut for this. Okay, now let's move on to the parallelogram. What is a parallelogram? A parallelogram has 2 pairs of parallel sides. Okay. So a parallelogram is so 2 pair of parallel sides. So this line is parallel to this one, and this line is parallel to this one. Okay, so a parallelogram has 2 pairs of parallel sides. Okay, now let's calculate label the sides. So this is known as the base of the parallelogram. And what is the height of the parallelogram? Is this going to be the height of parallelogram? No. Height must be perpendicular to the base. This means it must be at 90 degrees to the base. Okay? Always remember. I will write it down as well. But the height is always 90 degrees to the base. So this is the height. Okay? This is extremely important for you to understand that the height must be perpendicular which means that it is at 90 degrees to the base and it will be shown like this. Okay? And what is the formula to calculate the area of the parallelogram? It is base into height. So I'm going to write perpendicular height to make sure that you never forget that the height is perpendicular to base. So base into perpendicular height. Okay? So what is the area of a parallelogram? It's base into height. Height, which is 90. So it can also be inside the parallelogram. Okay, so this is also the height. This and this is equal because this is also 90 degrees to the base. Okay, so they can also give you the height inside. And what is the perimeter going to be? The perimeter is going to be the base plus this length plus the base plus this length. So this length is going to be equal to this length and this is the base. How we are going to calculate this length, it might be given in the question or they might, give us enough information to calculate this length. That is something that we'll deal with once we tackle questions. But you need to understand that the area is base into perpendicular height, whereas the perimeter is going to be the base plus this length plus base and this length. Okay? Now let's move on to the rhombus. A rhombus has two pairs of parallel sides and all four sides are the same length. That is why it is different from parallelogram. Here, these two sides are same, equal, and these two sides, the bases are same, right? For a rhombus, all four sides are equal. And it also has two pair of parallel sides. So it's going to be, oops. Okay, so all four sides are equal and this side is parallel to this side and this length is parallel to this one. Okay, and all four sides are also equal. A rhombus is a special type of parallelogram. So we're going to use the same formula to calculate the area as we've used in case of The parallelogram. A parallelogram has two pair of parallel sides. If all the sides are equal, then it is known as the rhombus. Okay? And because it is a special kind of parallelogram, the formula to calculate the area is going to be the same. Base into perpendicular height. Okay? And the perimeter is obviously going to be the sum of all sides. Since the lengths are equal, it's going to be 4L, just like in case of a square. Okay, now let's move on to triangles. Area of a triangle. Okay, so but the formula for calculating the area is half into base into, generally we call height, but I'm going to write perpendicular height so we have no confusions. To understand, in understanding the fact that the height is always perpendicular to the base. The height must be at 90 degrees to the base, always. Okay? Okay, now before I discuss this formula further, I want to ask you a question. So this is a triangle, a figure with three sides. Which of these three is the base? The answer depends on the height. So for example, if this is given to us, right? If this is the height, then this is going to be the base. Okay. However, if this height is given to us, then what is the base? Since this is the 90-degree distance, this is going to be the base if this height is given. Okay, and if this height is given, then your base is going to be this. Okay, so the base basically depends on the height given. So a triangle has three potential bases, base 1, base 2, base 3. Which base we are going to choose will depend on the height that is given to us. Okay? So always remember that we need the height, which must be at 90 degrees to the base. Okay? And the perimeter is going to be the base plus this length plus this length. Okay? Now the last shape that is left to be discussed is trapezium. This is a very important shape. It is also used in a lot of other chapters, especially kinematics. Okay, now how do you recognize a trapezium? A trapezium has one pair of parallel sides and the other two sides are not parallel. Okay, so it is a quadrilateral, which means it has four corners or four lengths, four sides, out of which two are parallel. Okay, so two sides which are parallel and two which are not. Okay, it can be like this. Okay, so this is parallel. So let's label the parallel sides as A and B. A, B, A, B. And what is the height going to be? It is going to be the perpendicular distance between the parallel sides. Okay, so these are the parallel sides. The perpendicular distance between the parallel sides is going to be the height. So if this is, so for example, if this is 90 degrees, then this is going to be the height. Okay, in this case, the perpendicular distance between the two parallel sides is going to be the height. So it can be given anywhere. Okay, so this is the height, or this is the height. The important thing here to remember is that the height must be at 90 degrees, or it must be the perpendicular distance between the two parallel sides. Okay, and the formula here, since this is 90 degrees, so this is going to be the height. And even if something inside is given, this this distance, the length between the distance between the two parallel sides is going to be the height. Okay, now the formula that you need to memorize is that the area of a trapezium is half into sum of parallel sides into perpendicular height. We generally write height. The reason I'm writing perpendicular height is because I want you to just, I want this to be hammered in your mind that it is always going to be um, the perpendicular height. So the height must be at 90 degrees to the parallel sides. Okay. So take care to use the correct dimensions. Remember that when working out the area of parallelograms, triangles, and trapezium, the base and height must be at 90 degrees. And it's not just for these shapes. If you have a look at the rectangle and square, even they are 90 degrees. Okay. So it is important to note that the two lengths that you will multiply together must be at right angles to each other, whether it's a square, it's a rectangle. I've now labeled these. This is a square. This is a rectangle. Parallelogram, rhombus, triangle, or a trapezium. Okay. Okay, let's very quickly put this knowledge to test. This is a page from the textbook that I generally use sometimes. So the title of the book is Mathematics for Cambridge IGCSE by Andrew Manning, Margaret Thornton, and Keith White. Okay. For each shape, work out the perimeter and the area. Okay. So first thing that you need to understand here, all the units are the same. But in case they're not the same, then you need to make the conversions and make sure that once you're calculating the area or perimeter, all the lengths are in the same unit. Okay, sometimes they will give you lengths in different units and to trick you. So make sure that you understand this, that before you calculate the perimeter or area, all the lengths should be in the same unit. Okay, so this is a rectangle. What is the area going to be? So length into width. So it's going to be, area is going to be 25 into 20 centimeters square, whatever the answer is. And what is the perimeter going to be? The perimeter is going to be 25 plus 20 plus 25 plus 20. Add all these four lengths together and you will get your perimeter. Okay, let's move on to B. So this is a square. Area is going to be 1.2 into 1.2. Answer will be in meters square, whatever answer you're going to get. And what is the perimeter going to be? 1.2 plus 1.2 plus 1.2 plus 1.2. Okay. Area of the triangle. The perimeter is going to be 20 millimeters plus 25 millimeters plus 15 millimeters. The area is half into base into perpendicular height. So this is the perpendicular height, right? So if this is the height, 15, then 20 is going to be the base. And if you consider 20 to be the height, then 15 is going to be the base. Okay? So half into 15 into 20 is going, this is going to be 150 millimeter square is going to be the area of the triangle. Okay, next we have a trapezium, right? So half into sum of parallel sides. So 10 plus 5. So half. And what is the height? The perpendicular distance between the parallel sides. These are the parallel sides. This is the perpendicular distance, right? So they've shown right angles. So 12 is going to be the height. So what is the area of trapezium going to be? Half into sum of parallel sides, which is 10 plus 5 into 12. This is going to be half into, first we're going to add them together, 15 into 12, right? And then you're going to solve it, and so on and so forth. What is the perimeter? It's 12 plus 5 plus 13 plus 10. Okay. What about this parallelogram? So the area is going to be base into the perpendicular distance, which is 60. Okay, why are we not taking 65 as the base? Because the height or the perpendicular distance is to this length. Okay, so this will be considered our base because the height should make a 90-degree angle with the base. So area is going to be 50 into 60. Okay, so 50 into 60, base into perpendicular height. And what is the perimeter of the parallelogram going to be? It's going to be 50 plus 65 plus 50 plus 65. Okay. Next, again, we have a trapezium. So half into sum of parallel sides. And what is the height? The perpendicular distance between the parallel sides. So it's going to be half into 1.6 plus 3.2 into 1.5. So first we are going to solve this bracket and then we're going to calculate the area. The perimeter is going to be 1.7 plus 1.6 plus 1.7 plus 3.2. Okay. Similarly, for this parallelogram, this is the perpendicular height, right? So, and this is going to be the base. So area would be 2.2 into 1.5. Perimeter would be 1.8 plus 2.2 plus 1.8 plus 2.2. So notice that we're not using the height in calculating the perimeter. Lastly, this is the perpendicular height given. So this is going to be your base. So half into base is 84. Perpendicular height is going to be 56. And this would be the area of the triangle. The perimeter would be 70 plus 84 plus 70. Okay, so I hope there's no problem in calculating the perimeter and area of these basic 2D shapes. Okay, on to the final shape, circle. This has been explored in a lot of detail in our syllabus. Okay, so before we get into that, let's make sure that our basic key terms are clear. The center is often labeled as point O or the center. Okay. What is the radius? Radius is a line segment from the center of the circle to any point on the circle. Okay, so this is radius, this is radius, 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 radius. All radii in a circle are equal. Okay, so this is the radius. What is the radius? A line segment from the center of the circle to any point on the circle. Okay. What is the diameter? Diameter is a line segment which passes through the center. So a line which passes through the center and connects 2 points on the circle. So any 2 points on the circle and it passes through the center. Any 2 points on the circle, so for example here, so any 2 points on the circle but passes through the center. Any 2, but passing through the center is a must, okay? So any 2 points by passing through. All of these are the diameters. So the diameter, let's mark it with black. It connects any 2 points on the circle, but it passes through. So this is the diameter. Diameter is twice the radius. Okay. So diameter is twice the radius. Okay, now what is the circumference of the circle? The circumference is the name that we use for the perimeter of a circle. Okay, so the sum of outer sides is the perimeter for a circle because it is curved path that the circle follows. This red line is basically the perimeter of the circle, right? This is known as the circumference. So this is the circumference. All of this. Okay, so this is the circumference of the circle, the distance around the circle or the perimeter. Okay, what is a chord? A chord is a line segment connecting any 2 points on the circle without passing through the center unless it is the diameter. Okay, so any other, so for example, let's use another color. Okay, so a line segment is basically chord, sorry. This is a chord. What is a chord? A line segment connecting any 2 points on the circumference of the circle. The longest chord of a circle is basically the diameter. The diameter passes through the center, but it is not necessary for different chords to pass through the center. Okay, so this is a chord, this is a chord, this is a chord. So a line which connects any 2 points on the circumference of a circle qualify as a chord. Now, what is the arc? Arc is a curved part of the circle between 2 points. So this is the arc between these 2 points. Okay. This is the arc between this and this point. Between this and this point, this is the arc. If we consider these 2 points of the diameter, then this is the arc. This is basically a semicircle. When the chord is the diameter and basically it's going to divide the circle in two equal parts, then this arc is going to be the arc of the semicircle. Okay, so let's highlight an arc. So this is an arc, example of an arc. Okay, what is a sector? A sector is a region which is enclosed between two radii and an arc. Okay, so two radii and an arc. So this is a sector. This is a radius, this is a radius, two radii and an arc. This is a sector. Okay, so as Sir Zan often calls that a sector, you can identify it as a pizza slice. Okay, so a sector looks like a pizza slice, a minor sector. Okay, we're going to get into the details of minor major sectors in a bit. So, but basically, you need to understand what a sector is. A sector is a region enclosed between two radii and an arc. Okay, so this is a sector, this yellow part. Example of a sector. So there are a lot of more sectors. So this yellow part is the sector. Okay, and then we have a segment. A segment is a region enclosed between a chord and the corresponding arc. So for example, if we consider this chord, and what is the corresponding arc? This is the arc. So this is a segment, okay? The small segment is the minor segment, and the bigger segment is the major segment. Again, we are going to get into the details of sectors and segments in a bit, but I'm quickly touching upon them so that you know all the terms related to a circle are clear. So this pink one is the segment. A segment is a region enclosed between a chord and the corresponding arc. It can be, this one is the smaller segment, and if we look at the other side of the circle, so this chord and this arc, so this is the major segment. Okay, so segment and sector, if you're not clear, don't worry about it. We are going to get into a lot of detail just as soon as we are done with calculating the area and circumference of circles. But please be sure that you understand what a diameter is, what a radius is, what the circumference is, what an arc is, what a semicircle is. This is a semicircle, okay? So the diameter divides the circle into two equal halves. Okay, now these were just the key terms. Okay, I'm sure all of you are aware of what pi is. I'm just going to briefly explain what it is. If you understand it, well and good. Otherwise, you can just leave it. So, the larger a circle is, okay, the larger it becomes. So this is a small circle. The larger the circle is, the larger its diameter going to be, and the larger its circumference is going to be. So the circumference, this is a small circle. The circumference of this circle is smaller than the circumference of this circle. Similarly, the diameter is smaller. The diameter of the larger circle is big. Okay. So, however, what you need to understand is that the circumference and the diameter of a circle are always in the same ratio. What it means is that the ratio of the circumference to the diameter remains the same. So basically, it's circumference divided by diameter is going to be the same no matter how small or how large the circle is. Okay, and this ratio is known as pi. Okay, so the ratio of the circumference to the diameter is always the same no matter how big or small your circle is, and this ratio is known as pi. Okay, just a brief, very small, brief history of pi. Okay, now area of circle is pi r square, where pi is the ratio of the circle circumference and diameter of a circle. I know that we've been used to taking pi as 22/7 or 3.14. These are estimations of pi, and until and unless this has been clearly stated in your question, what I'm going to request you is that please use, whenever we are performing calculations with pi, you're going to use the calculator value of pi. So there is a key on your calculator which has pi written on it. So whenever you're using or calculating areas or using basically pi, you're going to use the value which is stored in your calculator. If it's obviously P2. If it's P1, then either they're going to give you one of these estimations of pi or they're going to ask you to just leave your answer in terms of pi. Okay, but always remember that whenever you're performing calculations with pi, you're going to use the value on the calculator. Okay. And what is this formula for calculating the circumference of circle? 2 pi r. So you're going to memorize these two formulas. And if they ask you to find the area of a semicircle, semicircle is basically exactly the half of a circle. So it's going to be this area divided by 2. And if they're going to ask you to calculate the circumference of the circle, it's 2 pi r divided by 2. Okay. So this is going to be pi r squared divided by 2, and the circumference of a semicircle is going to be 2 pi r divided by 2. This will get cancelled out, so it's pi r. Okay. Let's very quickly discuss a couple of questions from circle. So if the question says that the circle has a diameter of 24 centimeters, calculate circumference and area. Very simple question, just to get into running. ठीक है? So circumference is 2 pi r. What is r? We're not given r, but we're given the diameter, which is 24. So half of 24 is going to be our radius, which is 12. So half of diameter is the radius. So it's going to be 2 pi into 12. Okay. So it's 24 pi, and you can calculate the exact value from your calculator. Now to calculate the area, the formula for calculating the area is pi r square. Pi, where the value of r is 12 square, so it's going to be 144 pi centimeters square. This is going to be centimeters, and this is going to be centimeters square. Okay, so pi r square is 144 pi, or you can calculate the exact value from the calculator. Okay, one very quick example where we're going to just slightly twist it. Okay, so if the question says that a circle has a circumference 1.57 centimeters, find the area of the circle giving your answer in millimeters square, correct to 3 significant figures. Okay, so the first thing that I want to urge my students to do is highlight or circle these terms. Okay, because sometimes you just find the answer and you forget the requirements of the question. Okay, next, to find the area, they're asking you to find the area of the circle. Okay, so to find the area, we need pi r square. So what do we need? We need radius. And that is not given to us in the question directly. However, they're telling us in the question that the circumference of the circle is 1.57. So what is the formula for circumference? It's 2 pi r, and that is equal to 1.57. Okay, so we are going to calculate our radius using this information. So 1.57 divided by 2 pi. Calculate this using the calculator, and it gives us, okay, so it is 0.2498 and so on centimeters. So I am not going to change this value on my calculator, and the future calculations that I'm going to do, I'm just going to press the answer key on the calculator so that my accuracy is not compromised while I'm going to calculate the answer. So we are required to find the area. So area is pi r square. So I am going to, if I was telling you what is on my calculator screen, it's going to be pi, the key of pi, and then bracket in answer, which is basically this value, square. So it's going to give you the most accurate answer. Okay, so pi r is 0.2498 square, and the answer that you get is 0.19615 centimeters square. Now they want you to give your answer in millimeter squares. Okay, so to convert from centimeters to millimeters, let's draw quickly. Draw our, okay, so this is 10. So we need to convert from centimeters to millimeters. What are we going to do? We are going to multiply by 10. And since we have a square, we are going to apply this rule twice. So into 10 into 10. So 1, 2. So this is going to be 19.615 millimeters square. And then you have to give your answer correct to 3 significant figures. So 1, 2, 3. The neighbor is less than 5. So your answer is going to be 19.6 millimeters square. Okay. I hope calculating the circumference or area of circle is no longer a problem for you. Now, before I touch upon sectors and segments, I want to quickly discuss composite shapes. Composite shape is made from simple basic 2D shapes. So for example, this is a composite shape. So this is not a rectangle or a square, but it is made up of basic 2D shapes. So this rectangle plus this rectangle is going to be how this composite shape is structured. Okay, so you can divide this composite shape into two shapes that we are aware of, and we know how to calculate the areas or the perimeters of such shapes. So area of this rectangle plus area of this rectangle will give you the area of this composite shape. And to calculate the perimeter, you're going to start from this point. So this length plus this plus this plus this plus this plus this. Okay. So using the same book, I'm going to discuss a few questions that are given to us in the exercise. Okay, so to calculate the area of a composite shape, sometimes you add the areas together. So like in this case, you're adding A1 plus A2. Okay, so area of this rectangle plus area of this rectangle is going to give you the area of the compound shapes. At times, so for example, if you have such a shape, okay, this, okay, and they're asking you to find the area of the shaded region. So now this ring is also a composite shape. It is made up of two circles. How can we calculate this shaded region? So in this case, what we're going to do is first we're going to calculate the area of the bigger circle. Once we have that, we are going to, okay, see. So first we're going to calculate this yellow, this area of the large circle. And then we are going to calculate the area of the smaller circle and subtract it from the area. So see, if we subtract the area of the small circle and see, what are we left with? We are subtract. So the thing that I'm erasing is what I'm subtracting. So what are we left with? We are left with this shaded region. So sometimes you need to subtract areas, sometimes you need to add areas. So that would depend on the shape in question. Okay, let's have a look at these shapes. Okay, so here if they're asking you to calculate, the perimeter is simple. All you have to do is add 3. Okay, so 3 plus 4 plus, okay, 5 plus 3. So you need to calculate what this length is. You can do that. So if this is 3, this is going to be 3. So this is 2. So this length is going to be 2. And to calculate this length, if this is 4 and this is 3, so this is going to be 7. Okay, so the perimeter of the shape is going to be 5 plus 3 plus 2 plus 4 plus 3 plus 7. And to calculate the area, you need to divide the shape into basic 2D shapes. So you're first going to calculate the area of this rectangle, which is going to be 4 into 3, and then this rectangle, which is 5 into 3, and you're going to add these two areas together. Okay. Similarly, let's skip to part C. Okay. So to calculate the perimeter, this is 12, 30, 40, 30, 12. You need to calculate these lengths. How are you going to do that? Okay, so if this is 12 and this is 30, so 30 minus 12 is going to be this length. Okay. And to calculate this, if this is 12, and all of this is 40, so 40 minus 12 or minus 24 is going to give you this length. Okay, so you're going to calculate all the lengths first and then add them together to calculate the perimeter. Now to calculate the area of this shape, you can divide this into 3 rectangles. So 12 into 30 plus 12 into 30 plus this length into this length, the ones that into 12 basically. So 40 minus 24 is going to give you this length into 12. And then you're going to add these 3 areas, A1, A2, and A3 together. Okay, let's skip to this one. Okay, so this shape is divided into a rectangle and 2 semicircles. Okay, because the diameter of the semicircles is the same, so you can consider it as one rectangle and one circle. Okay, so you can calculate the areas of these 3. You can calculate the area of this one and multiply it with 2, so you will have the area of these 2 semicircles, or one circle and this rectangle. Okay, here you can divide your shape into rectangle and triangle. Here you can divide into rectangle and a trapezium. Okay, now this is a very similar example to the one that I've discussed about the ring. So to calculate the area of the shaded region, first you're going to calculate the area of the bigger triangle, okay, which is this. Okay, so calculate the area of the entire triangle, which is 50 into 7. Then what are you going to do? Then you're going to calculate the area of the inner rectangle, not triangle, sorry, it's a rectangle, sorry. So it's a rectangle, okay? And then you're going to subtract the area of the inside rectangle, and you will be left with this orange part, okay? So first you're going to calculate the area of the bigger rectangle, all of this, and then you're going to subtract this from the bigger rectangle, and what are you going to be left with? This orange part. Okay, see, what are you going to do about this shape? So first, what you're going to do is you're going to calculate, you need to basically calculate this blue area, okay? So first, you're going to calculate the area of the rectangle, okay? This rectangle. And then you're going to calculate the area of the square, circle inside, and then you're going to subtract that area. So I'm going to erase the area that we are going to subtract, okay? So this is what we're going to subtract. And what are we going to be left with? This area, which is blue in the question. Okay? Okay, let's move on to the next question. To calculate the area of the shape, you are first going to calculate the area of the semicircle. Okay? And because, see, this is going to be equal to this one. This is 32. If this is 16, this is 16. So basically, this will fit exactly into this shape, right? So you can just calculate the area of the semicircle, and you will have the area of this shape. Why? Because this part that we were going to subtract, and then we had to add this part to the shaded region. This is exactly the same as this part. So we can just simply calculate the area of the semicircle to find the area of the shaded region. Okay, here we're first going to calculate the area of the circle. And then we're going to calculate the area of one triangle. It is given in the question that all 5, all 6 triangles are equal. So first we're going to calculate the area of the triangle, multiply it with 6. So we will have the area of this white region, okay? And then we have also calculated the area of the circle. We are going to subtract this area of 6 triangles from the circle, and it will give us this purple part, okay? Here we're going to calculate the area of this big semicircle, and then we're going to calculate the area of these small semicircles, and we're going to add them together and subtract them from the area of the big semicircle. So what are we going to be left with? This region. Here we're going to calculate the area of the rectangle. Then we're going to calculate the area of this semicircle and this semicircle and add all the 3 areas together. Also, another thing that I want you to keep in mind is that if I ask you to find the perimeter of a semicircle, okay, so what are you going to do? This is basically the diameter, right? So first you're going to find the the circumference, half circumference, right? So you're going to find that by 2 pi r divided by 2, which is pi r, and then you're going to add the perimeter, the diameter. Okay, why? Because perimeter starts from one point. So you find this arc, semi-arc, using the formula for the circumference of the circle, of the semicircle, and then you also need to add this diameter to calculate the perimeter of this entire shape figure. Now we are going to explore circles in detail. Okay, now there are 2 ways to divide a circle. The first one is where you divide it using a chord. What is a chord? What is a chord? A line segment with its endpoints on a circle, right? So a quick recap of what we have covered. A chord is a line segment with 2 points on the circumference. Any point line originating from the center and touching the circumference of the circle will be the radius. Okay? So in this case, the circle has been divided into segments. So the small one is known as the minor segment, and this big one is known as the major segment. Okay? So this is the major segment, and this is the minor segment. Okay, I'm going to color these so you would know what the segments are basically. So this green highlighted part is the major segment. Sorry, the minor segment. And this lilac purple part is the major segment. Okay, so this is the major segment. Okay, I am going to get into the detail of this later. We are first going to touch upon the second way of dividing a circle. A circle can also be divided into 2 parts. The parts are known as sectors by 2 radii. So what does that mean? So if this is the center, any 2 radii is going to divide your circle in this shape, okay? So this small sector, this is known as sector. This small sector is known as the minor sector, and this big sector is known as the major sector. Okay, so these sectors, Cezanne calls this minor sector as a pizza slice because yes, it is shaped like a pizza slice. Okay, and this major sector is known as Pac-Man. Okay, so if you know those terms, you can utilize them as well. Okay, So this is major sector and this is minor sector. Okay, so this is minor sector and this is the major sector. Okay, so what are the two ways of dividing circles? You can either divide them into sectors or segments. Okay, we are going to deal with each one in detail. Let's begin with sectors first. So a circle can be divided into two parts called sectors by two radii. Okay, so this is the sector and it can be in any direction. So for example, let's make this is the set. Okay. So this is the minor sector and this is the major sector. Okay. Also, just a quick revision. What is this known as? This is known as the arc. Part of the circumference of a circle is known as arc. It is a curved line. Okay. So this is the minor arc and this is the major arc. Okay. So just so that there's no confusion, let's mark this. This green one is minor arc and this is major arc. Okay. And a sector is a region of a circle that is contained by an arc and two radii. So sector is region of a circle which is contained by an arc and two radii. Okay, an arc and two radii. So I hope we're clear with the definition and the terms. O is the center of the circle and let's label this O, A, A, B. Okay, so O, A, and let's mark B here so that we're not confused as to which sector we're talking about. So OAPB is the major sector. OAPB is the major sector. And arc APB is the major arc. And OAQB is the minor sector. And arc AQB is the minor arc. Okay, now what are the formula? You need to memorize the formulas for calculating the arc length and the area of sector. So the formula to calculate the arc length is very important. Arc length is theta over 360 into 2 pi r. Okay, so see, what is the formula for calculating the circumference of the circle? It's 2 pi r. arc length is part of the circumference. Kitna part? Theta over 360. So this entire thing, we know that angles around a point, they add up to 360, right? Now, if we're calculating the minor arc, so we're going to find this angle. Let's say this is theta. So this angle, theta, this is theta. So theta over 360. So this is basically the fraction of the arc length. Okay, so basically what we're trying to do is we're trying to express this minor arc length as a fraction of the circumference. So कितना part है circumference का? ये देखो, अगर ये पूरा 360 है, so the entire circumference represents 360 degrees. This minor arc is represented by theta. Okay, so whether you understand this or not, this is the formula for calculating the arc length. Now, if it is the minor arc length, we're going to use the value of theta as this. However, if we're calculating the major arc length, then we're going to find this value and we're going to put this as theta in the formula. Okay, and how are we going to calculate this major theta? So for example, if they tell us that this is 70, say this is 60, okay? And we know that this entire thing is 360. So 360 minus 60 would give us 300. So if they're asking us to find the minor arc, we are going to substitute theta is equal to 60. So it's going to be 60 over 360 into 2 pi r. And if they're asking us to calculate the major arc, we're going to use 300 as the value of theta. So 300 over 360 into 2 pi r. Okay? Similarly, to calculate the area of a sector, what is the formula for calculating the area of a circle? It's pi r square, but sector is just part of the circle. So it's going to be theta over 360 into pi r square. Okay, so it's very easy to remember because arc length is part of the circumference. How do we calculate the circumference of the circle? It's 2 pi r. So theta over 360 into 2 pi r to calculate the arc length. To calculate the area of the sector, it's theta over 360 into pi r square. Pi r square is basically the formula for calculating the area of the circle. Again, if we're calculating the area of the minor sector, we're going to use this red value of theta. In case they're asking us to find the area of the major sector, then we're going to use this green value of theta. Okay, let's do an example to make sure that you guys understand this. Okay, so let's say that an arc subtends an angle of 105 degrees at the center of a circle of radius 5 centimeters. Okay, the first part asks us to find the area of minor sector, and part B asks us to find arc length of major sector. Okay, so it's best if you quickly draw a sketch of whatever is given to you in the question. So an arc subtends an angle of 105 at the center of a circle. So let's draw a circle quickly. Okay, and radius is 5. So 5, 5, and the angle subtended from the center is 105. Okay, so this is what your figure looks like, or this is what the question is basically telling you. This is a visual representation of the question for your understanding. Now let's solve. So they're saying that find the area of the minor sector. Which is the minor sector? 2 radii, and the minor arc is basically the minor sector, and we are going to use this angle. So the area, what is the formula for the area of a sector? Area of minor sector will be angle over 360 into pi r square. Let's substitute the values. So theta is 105, r is 5. Let's plug these values in. So 105 over 360 into pi, r is 5 square, and this comes out to be, let's calculate, 22.9 centimeters square. Again, a reminder that you're going to use the value of pi that is stored in the calculator. You're going to use the pi key in your calculator to calculate anything that the question asks you in P2. Okay? Okay, now let's have a look at the second part. Find the arc length of major sector. Arc length of major sector. So it's going to be this arc length of the major sector. Okay, and to calculate this, we need this angle. Angle of the major sector. What is this angle going to be? Since the total is 360, we are going to subtract 105 from 360, and we will have this angle. So let's solve this question and okay. So what is the angle going to be? It's going to be 225. Okay, so 360 minus 105 is going to give you 225. So what is the formula for calculating the arc length? Major arc length, because we're going to use okay, so it's theta over 360 into 2 pi r, where theta is it's 225, r is going to be 5 centimeters. Don't forget to put in your units. So 225 over 360 into 2 pi r is 5 is going to give you 22.3 centimeters. Okay, so I hope that this is clear and there is no confusion in which angle you're going to choose when you're calculating the arc lengths or area of sectors. Let's do a very quick example and then we can move on to segments. Okay, so if a sector of a circle of radius 8 centimeter has an arc length of 16 centimeters, find the area of the sector. Okay, so they've not given you, no, they've given you the radius here, but they've not given you the angle. Let's highlight key pieces of information. Okay, so a sector of a circle has the radius is 8 centimeters. I always used to, as a student, I would always jot down key pieces of information. So radius is 8 centimeters. Arc length, which is basically theta over 360 into 2 pi r, that is equal to 16 centimeters. Okay, and they want us to find the area of sector which is theta over 360 into pi r square. Okay, so we have all the key pieces of information written down. I hope there's no confusion here. The radius is 8 centimeters. The formula for calculating the arc length is this, and they've given us the value of the arc length in the question. So this formula is going to be equal to 16 centimeters, and we need to calculate the area of the sector, which we can find using this formula. So let's see what we need to find. So we have the radius. We shouldn't worry about that, but we need to find theta because we don't know what the value of the angle is. How are we going to find the value of the theta? The question will always give you something that would help you to find the value of theta. So that help is this. So theta over 360 into 2 pi r is 8 is equals to 16. And you're going to use this equation to find theta, which comes out to be 114.591 degrees. Also, please never round off your workings. You can only round off your final answer to 3 significant figures. And if it's an angle, you can round it off to 1 decimal place until and unless something else has been stated clearly in your question. But please don't round off your workings, okay? If I was a student, I would keep this answer on the calculator, and then later when so basically we have to find the area of sector, which is theta over 360 into pi r is 8 square. So what I would do is that I would take out my calculator, and obviously this is on the calculator. So I would enter answer divided by 360 in brackets. Okay, so let's write it how it would be appear in the calculator. So brackets answer divided by 360 multiplied by 64 pi. And then I would press the equal to sign. And then you would get the most accurate answer. Okay, which comes down to 64 centimeters. 64 centimeters square. Okay, so this is all that we're going to discuss about sectors. Now we're going to move on to segments. Now, what is the second way to divide a circle? As already discussed, a chord divides a circle into 2 parts called segments, right? So this is a chord. This line is the chord, and this is the major segment. And this okay, and this is the minor segment. Okay, so the larger part is called a major segment, and the smaller part is called a minor segment. A chord is basically a line segment with its endpoints on the circle. A diameter is the longest chord, and the diameter would basically cut your circle or divide your circle into 2 equal parts called semicircles. Okay, so when the chord passes through the center and it is the diameter, it would divide your circle into 2 equal parts known as semicircles. Okay, now let's get into the details of working with segments. here we are going. I hope all of you remember how we calculated the areas of compound shapes, right? Okay, so if they ask us to find the area of the minor segment, so there is no one formula that we have that can help us to find this area. So what are we going to do? Just like we do in case of compound shapes, we are going to try and divide this shape into, or we're going to divide it into shapes that, we know the formula to calculate area of. Okay, so this is the center. This is the radius, right? So this is the first part of the circle. This triangle is the second part, and this major this major sector is the third part. Okay, so initially we had two segments, but now we have divided these segments and the entire circle into three parts. So the first one is this part, the second is the triangle, and the third is this major sector. Okay, now if we are to find the area of this minor segment, and we do not have a formula that we can directly apply and evaluate it, but we know how to calculate the area of the minor sector, right? We know how to calculate the area of the minor sector. So let's draw this sector outside. Okay. So how can we calculate the area of the minor sector? Theta over 360 into pi r square. So applying the formula, we are going to calculate the area of this entire sector. Okay. So this is area of the triangle and the area of the sector combined. But we only need the area of this minor sector. So what are we going to do? Then we are going to calculate the area of this triangle. Okay. So first we are going to calculate the area of minor sector using the formula. And then we are going to find the area of the triangle, and we are then going to subtract the area of the triangle. So I'm going to, whatever I'm subtracting, I'm going to erase. Okay, so we calculated the area of this minor sector, and then we calculated the area of the triangle, and then we subtracted the area of the triangle from the minor sector. So what are we left with? See, we're left with the area of the minor segment. Okay, I hope this is clear. If not, please replay this part. This is very important, so you have to absolutely understand it. So what we're going to do to calculate the area of minor segment, we're going to calculate the area of the minor sector, and then we're going to subtract the area of triangle, and that will give you the area of the minor segment. Okay, again, so what we did, we calculated the area of this entire sector, minor sector, okay, and then we calculated the area of this triangle. So then after that, we have the area of this sector, and then we're going to subtract the area of the triangle. So what are we going to be left with? We are going to be left with, so we subtract the triangle, and we are left with the area of the minor segment. Okay. Okay, now what if they ask us to find the area of major segment. Now let's have a look at our major segment. So this entire thing is the major segment, right? This is the major segment. Now, if you look at it carefully, it is made up of two shapes that we know how to calculate the area of. So the first shape is this triangle, and the second is this major sector, right? The Pac-Man. So we know how to calculate the area of the major sector, and we also know how to calculate the area of the triangle. So we are going to calculate these two areas, and we're just going to add them together. So this is comparatively simpler. So the area of major sector is going to be the area, major segment is going to be the area of major sector plus area of triangle. Okay, and if they ask you to calculate the arc length, then that's simple using the same, formula that we learned in calculating the arc length of major and minor sectors, right? Because ये देखो ना, ये वाला major segment का जो arc है, वो basically minor sector की arc है. And similarly, जो major segment की arc है, that is also the arc of the major sector. So for segments, the only new thing that you have to learn is how to calculate the respective areas. For major area of major segment, it's not difficult. This is your major segment. We can divide your major segment into two shapes. One is triangle, one is major sector. You calculate the areas and add them together. For minor segment, you're going to calculate the area of the minor sector, and then you're going to subtract this area of the triangle, and you will be left with the area of the minor segment. Okay, hopefully this is clear. Again, if you have any confusions, please rewatch this part to make sure that you understand it. Okay, let's do one example to put this knowledge to practical use. Okay, so a circle with center O has a radius a chord. So a circle with center O has a radius of 17 centimeters. A chord PQ is drawn 15 centimeters from the center. Find the length of the chord PQ. And then second part is calculate the area of the minor segment that is cut off by the chord PQ given that the acute angle POQ is equal to 56.14 degrees. Okay, so let's quickly visually represent our question. A circle with center O. So let's draw a circle with center O. Has a radius of 17 centimeters. So this is our 17 centimeters. A chord PQ is drawn 15 centimeters from the center. So center से आपका PQ कितना? Let's draw PQ first. Wait. So let's say this is PQ, PQ, and it is 15 centimeters from the center. Okay, so this is the distance. It is going to be the perpendicular distance, obviously, so it's going to be 90 degrees. So they're asking you to find the length of the chord PQ. Now here we're going to use Pythagoras. I hope all of you know what it is and how to put it to use. So let's draw the triangle outside. So this is 17, this is 15, this is a right angle triangle, and we need to find this length. Okay, let's label our sides. The side opposite to the right angle is the hypotenuse, and the other two legs we will just denote them by A and B. So basically 8 square is equals to A square plus B square. This is Pythagoras. 17 square is equals to 15 square plus x square. So x square is going to be 17 square minus 15 square. X is going to be 8. Okay, so this is 8. Obviously the perpendicular distance or the perpendicular line, the distance is going to divide PQ into two equal parts. So if this is 8, this is going to be 8. So what is the length of the chord PQ going to be? PQ is going to be 16 centimeters. Okay. Second part, calculate the area of the minor segment that is cut off by the chord PQ. So cut off by the chord, this is PQ, and this is the area that they're asking us to find. Given that the acute angle POQ, why they're saying acute? Because POQ can also be this angle, right? So this small one is going to be the acute angle. So they're saying that POQ is 56.15. Okay, so just to avoid any confusions, let's draw this here. Okay, so this is 56.14. This is 17, and this length is 16. Okay, now let's first calculate the area of the. So how are we going to calculate the area of the minor segment? Area of minor sector minus area of triangle. Okay, so what is the area of minor sector? Theta over 360 into pi r is 17 square. Okay, and this is 141.15. Eight centimeters square or 6 centimeter squares. Anyways, it's something close to this. Okay, so now we have calculated this yellow highlighted area. Okay, but we just need to calculate this area. We need this area. So what are we going to do? We're simply going to subtract the area of this triangle. Luckily, we are also given the height, which is 15. Okay, so let's draw this triangle outside so we have no confusions. This is 15, and this is 17. This is 16, this is 17. So what is the area? Area of triangle going to be? Area of triangle is half into base into height. So this is the height, and what is the base going to be? It's going to be 16, not 17. Why? Because we always determine the base of the triangle with the help of the height. So the height is basically 90 degrees. It makes a 90-degree angle with the base. So the height is making a 90-degree angle with this PQ, which is 16. Okay, so it's going to be half into 16 the base into height, which is 15. So this comes out to be 120 centimeters square. So what is the area of segment going to be? Area of minor segment. It's going to be the area of the sector, minor sector, which is 141.58 minus, so what are we doing effectively? Please look on this figure. So we've calculated this yellow part, which is area of the minor segment, and now we are subtracting the area of the triangle. So what are we left with? See, we're left with the area of the minor segment. Okay, so this is 120, and you get 21.6 centimeters square. Your answer correct to 3 significant figures. And that's a wrap on this mensuration lesson. I hope everything's starting to make more sense now. Very soon I'll be uploading a new video where I go through past paper questions from easy to challenging ones, so you can see how to apply everything we've covered in this video. Between this video and the upcoming practice one, you will have everything you need to master this topic confidently. Don't forget to like, subscribe, and turn on notifications so you don't miss it. See you soon. Good luck.